Dear students, we are going to discuss formation of differential equation from the topic differential equation. In our last lecture we have solved some examples from the exercise 8.2. Today also we are going to solve some examples from that exercise. So let us see the question here, that is, obtain the differential equation by eliminating arbitrary constants. You know the procedure because already we have discussed in our last lecture. Okay, so let us see. Now see, the function is given y is equal to c2 plus c1 upon x. We have to eliminate c1 and c2. There are two constants, two arbitrary constants, and we have to differentiate this given function with respect to x two times because c1 and c2 are two arbitrary constants. So the differential equation that we will form is of order second order derivative. Okay, so see in answer, first of all I will write the given, that is y is equal to c2 plus c1 upon x. Now if you differentiate this with respect to x, now if you observe here, then c2 is a single constant, so that can be removed by taking the derivative. So by first order derivative, here you will get dy by dx, and the derivative of single constant c2 will be 0, plus now here it is c1 as it is into derivative of 1 upon x is equal to minus 1 upon x square. Okay, as we know that derivative of 1 upon x is minus 1 upon x square, and hence what we get here, we get dy by dx is equal to minus of c1 upon x square. Okay, now to remove c1 constant that we have to remove, now again we have to differentiate this with respect to x, but we will modify this first order derivative as, let us see here, I will write here x square into dy by dx is equal to minus c1, and minus c1 becomes a single constant. So if we differentiate after this step, then c1 also will be removed. So differentiate with respect to x both sides. So here to the left hand side we require u into v rule. So x square into dy by dx. So I keep x square as it is into take the derivative of dy by dx, that is d square y upon dx square, plus dy by dx as it is into derivative of x square is 2x, and to the right hand side the c1 will get eliminated because the derivative of minus c1 is 0. So both the derivatives are completed here, means up to second order derivative we have completed it, and also we have removed the arbitrary constants also. So what we get after this, we get the differential equation, that is x square into d square y upon dx square plus 2x into dy by dx is equal to 0. Now here also you can divide by x and you will get the final answer as x into d square y upon dx square plus 2 times dy by dx is equal to 0. So this will be a required differential equation by eliminating arbitrary constants. Okay, now let us see another function, that is y square is equal to x plus c bracket cube. Now here only one constant is there, so we have to differentiate this function with respect to x only one time. Okay, but after getting the derivative, is it possible to remove the constant c? See here, just I will show here in answer if I differentiate this, because we require to differentiate only once. So here it is given that y square is equal to x plus c bracket cube. If you keep this function as it is, then it is impossible to remove this constant. So what will you do here? Take cube on both sides. So taking cube root on both sides, actually taking cube root on both sides, what will you get here? Y square's cube means y raised to 2 by 3 is equal to x plus c. And now if you differentiate this with respect to x, then c will get cancelled because c will be a single constant. Here it is not possible. Okay, so differentiate both sides with respect to x. Then derivative of y raised to 2 by 3, it will be 2 by 3 y raised to 2 by 3 minus 1 into dy by dx. So see the derivative of y raised to 2 by 3 carefully, and it is equal to right hand side contains x, derivative of x is 1 plus derivative of c is 0. So constant is eliminated. Also the derivative is also completed because c is only one constant. So just you rewrite this. So 2 by 3 into y raised to 2 by 3 minus 1 means minus 1 by 3 into dy by dx is equal to 1. Then what will you get? Just rewrite this in a standard form. So you can write it as 2 by 3 into 1 upon, this is cube root of y, cube root of y into dy by dx is equal to 1. Or you can rewrite this as dy by dx is equal to 3 into cube root of y upon 2. So this is the differential equation. So we have formed the differential equation by eliminating only one constant which is given here. So just we have to differentiate this with respect to x, means we need the first order derivative only here in this case. So for that, to remove that constant, we have to take the cube root on both sides, because after taking cube root, that constant c will remains as only a single constant, and if there is a single constant, then it is very easy to remove. Okay, so that's why we have completed this answer like this. Now see the next example. The function is given y is equal to c1 plus c2x bracket complete into e raised to x. Now here there are two constants, so we have to differentiate this 2 times. So let us consider the given function y is equal to c1 plus c2x into e raised to x. Now before differentiating this, you have to divide both sides, or you have to multiply both sides. Multiply both sides by e raised to minus x. Then what will you get? Y into e raised to minus x is equal to, here e raised to x will get cancelled, and we get c1 plus c2x just. And because of this, now see here, this constant c1 is a single constant. So now if we differentiate this with respect to x, so differentiate with respect to x, and after taking the differentiation, the c1 will get cancelled. So that is the main purpose, that we have multiplied both sides by e raised to minus x, so that c1 becomes a single constant. Now take the derivative here. So derivative of y into e raised to minus x, keep y as it is into derivative of e raised to minus x is minus e raised to minus x, plus e raised to minus x as it is into derivative of y is dy by dx, and on the right hand side derivative of c1 is 0, plus now derivative of c2 into x, c2 as it is into derivative of x is 1. Okay. Now after this step, just you rewrite this step as y into minus y into e raised to minus x plus e raised to minus x into dy by dx is equal to, we get C2 here. Now if you observe this step carefully, then if you differentiate again with respect to x, then C2 will get cancelled. Okay, so automatically after this step you have to differentiate both sides with respect to x. Now here it is minus y e raised to minus x. Minus keep as it is and apply the rule for y into e raised to minus x. So keep y as it is, and derivative of e raised to minus x is minus e raised to minus x plus e raised to minus x as it is into derivative of y is dy by dx by using u into v rule. So it is completed, plus now in next bracket differentiate e raised to minus x into dy by dx. So keep e raised to minus x as it is into derivative of dy by dx is d square y upon dx square plus dy by dx as it is into derivative of e raised to minus x is minus e raised to minus x. So it is completed, and on the right hand side it will be 0. So we get the differentiation. So up to second order derivative we have completed the derivative, and while completing that derivative we have eliminated constants also. So our procedure is completed. Now just you modify this. Now there are for every term there is e raised to minus x, so that can be removed by dividing both sides by e raised to minus x. What will you get? Everywhere e raised to minus x will get cancelled. So here you will get minus y plus dy by dx. Just you remove e raised to minus x, plus in the second bracket you will get d square y upon dx square. Just you remove e raised to minus x. So here the minus sign remains as it is. So minus dy by dx is equal to 0. Now next step, after removing this, now minus minus plus y minus dy by dx plus d square y upon dx square minus this is dy by dx is equal to 0, and hence we get the differential equation, that is d square y upon dx square minus 2 times dy by dx. See, minus dy by dx and minus dy by dx, that is minus 2 times dy by dx plus y is equal to 0. So this is the differential equation by obtained by eliminating arbitrary constants. Okay, thank you.